Welcome to this explainer. Today, we are taking the scientific method, ripping it right out of the laboratory and bringing it straight into your kitchen. We're going to see how a simple, structured five-step approach, well, it isn't just for folks in lab coats. It's actually your ultimate tool for solving everyday mysteries with absolute certainty. So let's kick things off with a little challenge. Think about a super common situation. When you want to know which brand of soap removes dirt faster, what do you actually do? Do you rely on guesses, hearsay from a neighbor, or maybe some flashy advertisement? Or do you go out and look for actual concrete proof? Because that difference, the gap between just guessing and actually proving, is exactly what we're focusing on today. Just think about the difference between a guess and a test. If you say the water swallowed the salt, well, that's just a creative guess, right? But saying salt dissolves in water and we can time it, that completely changes the game. That second statement, it can be actively tested, measured, and actually proven. And to make that leap from just guessing to actually proving, we use a highly structured step-by-step formula to uncover the truth. So here is our ultimate roadmap, the 5 steps of scientific investigation. We've got aim, materials, method, results, and conclusion. Let's break down exactly how these puzzle pieces fit together. Step 1, it all starts with the aim, or the problem. You've got to know exactly what question you're trying to answer before you do absolutely anything else. Without a razor-sharp aim, honestly, you're just wandering around in the dark. All right, once you've nailed down that aim, step 2 is gathering your materials. This is pure preparation. It's taking inventory so you don't have to suddenly pause a crucial test right in the middle just because you forgot, a really vital component. Next up is step 3, the method. And this perfectly illustrates the rigorous nature of science. Your procedures here have to be incredibly clear, step-by-step instructions. Basically, they need to be so precise that someone halfway across the world could repeat your exact test and get the exact same answer. Then we hit step 4, the observation phase. Results and data. This step requires meticulous measurement and, perhaps more importantly, absolute honesty. You are recording exactly what happens, not what you kind of secretly hoped would happen. And finally, step 5, the conclusion. This is where the guesswork officially dies. You look back at your initial aim and you confidently answer it, based strictly on the hard data you just collected. Hey, if the numbers don't support your gut feeling, well, the numbers win. Okay, let's see how this actually builds in the real world. We are going to take these 5 steps and apply them to a classic, hands-on investigation, the saltwater test. Setting our aim or problem for this one, we want to know a really specific thing. Does adding more salt to the exact same amount of water change how fast it dissolves? It's a super straightforward question, and it is perfectly testable. So we gather our materials. And no, we aren't using any fancy industrial lab equipment here. We just need some clear cups, a measuring spoon, salt, water, a stirrer, and a cell phone timer so we can track things precisely. Now, for our method, we absolutely have to ensure what's known as a fair test. We do this by using the exact same amount of water in each cup and maintaining the exact same stirring speed for all 3. The only thing we're changing, the only variable, is the amount of salt. We put 1 teaspoon in cup 1, 2 in cup 2, and 3 in cup 3. Doing it this way guarantees that any difference in time is strictly because of the salt, not because of how much water we used or how wildly we stirred. As we execute that method, stirring and carefully watching the salt dissolve in each cup, we move immediately into the observation phase. We've got to meticulously record our results the absolute second they happen. To do this right, we organize our observations into a data table. This keeps our thoughts clear and our evidence totally structured. We measure exactly how many seconds it takes for the salt in each specific cup to completely disappear, and we write it down immediately. And right here is a really crucial rule pulled straight from our source material. You must record the actual result, even if it completely surprises you. Like maybe you assumed cup 3 would dissolve instantly, but your timer says otherwise. In science, you've got to record what actually is, not what you wish it was. Moving into our conclusion step, we review that data to see which cup actually dissolved the fastest. We answer our initial question based exclusively on the reality of those numbers. And boom, just like that, we've transformed a simple curiosity into an undeniable, proven fact. So, what does this all mean? Why go through this highly structured approach just for mixing some salt and water? Well, the beauty of these 5 steps is that they don't just live in a classroom setting. They actually scale to almost everything we do. Think about it. These 5 steps scale up to almost everything in your everyday life. Whether you're tweaking a recipe so you don't completely ruin Thanksgiving dinner, figuring out how to safely mix cleaning detergents for a stubborn stain, or even investigating why your street floods every single time it rains, this exact method applies. Aim, materials, method, results, conclusion. As the source material brilliantly summarizes, this process shifts us entirely away from hearsay and superstition. It empowers us to confidently test our own ideas using real, tangible proof. You essentially become the lead investigator of your own life, making decisions based on solid evidence rather than just, taking someone else's word for it. All right, now it is your turn to take the reins. The source material actually leaves us with a classic kitchen investigation of our own. Does sugar dissolve faster in hot water or cold water? I totally challenge you to apply these 5 steps to find out for yourself. Define your aim, write out a fair method, and then let the results do all the talking. But beyond just sugar and water, I want you to ask yourself, what other assumptions in your daily life are just sitting there, waiting to be tested? It's time to stop guessing, start investigating, and go find the proof. Thanks for joining me for this explainer, and I'll catch you next time.